Today we're going to be putting together another Raylib demo, this time for the arcade game Asteroids. The thing is, I've never really played it. I'm going to take a lot of creative liberties on how I think the game will operate. At certain points I may refer to how the original game is laid out, but for the most part I'm just going to focus on getting some of the core features that I know we're going to need. So in this video I'm going to get some asteroids spawning at the edges of the screen, have them pick a path that will take them across the screen, also make it so that each one has their own variable spin, just to kind of give some more variety to how they look. The first thing I'm going to do is create a basic struct for an asteroid. I'm going to be following the workflow that I showed in my VS Code video, so I will be using multiple C files for this project. In order to describe the asteroid's position, I'm going to need to use a vector, which means I'll need to include Raylib in this header. The asteroid's going to have a position, a rotation speed, and a velocity. I'm also going to create an enum to define an asteroid size. So I have an enum called asteroid size, which has a small, medium, and large value. I'm going to give these kind of odd values, but my intention is that a large asteroid will split off into two medium asteroids, and each medium asteroid will split off into two small. So the value of the enum will actually indicate to us how many entries in the asteroid array that asteroid should result in. I'm also going to add a bool at the beginning of the asteroid called active, which I'm going to use to indicate whether an entry in the array is actually representative of an asteroid which needs to be updated and drawn. Next, I'm going to create a function for generating an asteroid. For now, I'm just going to take a position and a velocity. For the rotation, I'm going to use a random rotation between 0 and 360. And for rotation speed, I'm going to set it up a little differently. I'm going to have a minimum speed of 5 degrees per second and a maximum speed of 240. So in the first case, I'm getting the random value using the classic C method, which I'm using rand, which will return a random integer between 0 and some gargantuan value. And I'm using the modulo operator to restrict it to numbers less than 360. So I'll get values 0 to 359 as a possible value. In the second case, I'm using a Raylib helper miscellaneous function, which does pretty much the exact same thing under the hood. The difference here is that it allows me to easily specify a minimum and a maximum value. Now at this time, I'm able to initialize everything about the asteroid all at once, so I'm just going to change this function to work this way. So really what this function is doing is we're taking these two values that we know we want to set about the asteroid, and the rest it's just pumping them in. Of course, I forgot to use my enum. This is going to be an important piece of the asteroid as well. I'm also going to quickly create an update asteroid method. I want to use this vector2 add function and vector2 scale from raymath, but I can't use them because I haven't included raymath, and right now I'm actually putting implementation inside of the header file, so let's quickly fix that. Now I can see it wants me to include the proper headers to actually use the rand function, so I'll just use the Raylib one instead. It's just as easy. So we can see when we want to update an asteroid, I want to add to the position the current velocity scaled by frame time, and I also want to change the angle. So I've got the code to create an asteroid and the code to update an asteroid. Let's try and set this up really basic in the main file just to see that the position and rotation are working as we expect. Don't forget to include your custom header file in your main file. I'm going to define a preprocessor constant for how many asteroids I want in the array, and I'm going to create a static array for those. I'm going to use this to initialize every entry of the array to 0, which should also include setting all of the active values to false. In update, when I iterate over all of the asteroids, I'm going to check if the asteroid at I is active, and if it's not, I'll just continue. Alternatively, instead of writing this out here, I could grab this logic and actually place it inside of asteroid update. I think I actually prefer this, so I'll stick with this. The next thing I was going to do is make it so that an asteroid spawns where I click, but I realized we need a way to draw the asteroids first. For now, I'm going to draw these as triangles just so we can see the rotation. I'm going to use draw polylines. I'm going to change the clear background to be a near black instead of a ray white. I just like to use this color that's very, very dark, but not quite black. Kind of like how Ray likes to use something that's almost white. So after we clear the background, we can do the same loop, only here we want to do an asteroid draw. Of course, one notable problem here is I forgot to add this to the header. Whenever we press the left mouse button, I'm going to try and add a new asteroid at the mouse's position. I just need to create this function. To add an asteroid, we can just have a new asteroid here. And next what I want to do is iterate through the list of asteroids. And I want to continue any past asteroids that are already active. If we're still in the loop, but we're past this if statement, we know that the current index is safe for me to insert an asteroid. And I can simply copy in this value. Another way to think about this is I can actually create it here, and I'm going to create a bool called created, which defaults to false. When we do this, we set it to true, and after the loop, if we did not manage to create one, then I think that's relevant information for the log. Also, in the case where we successfully create the asteroid, we're going to want to make sure that we break so that we don't fill the array with asteroids. Okay, so to the update draw frame, I added an asteroid update for every single asteroid in the array. I added a function where if I press the left mouse button, it'll spawn an asteroid at that location. And I added to the draw loop a chance to actually draw those asteroids. Well, it's letting me place asteroids, and they seem to have random rotations, which is good, and if I do a bunch of them it looks really neat, but they don't seem to be moving. This is pretty funny. I realized that in my update method I actually got this backwards. It's if the asteroid is not active, do I want to return? And there we go. Now we can see we can create these projectiles, they have different spins, and they slowly move to the right. The next thing I want to do is make it so that the size value I use actually controls the radius of the shape that's drawn. In this case, I'm happy to use 16 as a base size. This will make regular asteroids 16, medium ones will be 32, and then the large ones will be 64. Next, I want to make this a randomized value, and I think this will be really easy to do. I'm doing this in a bit of a strange way, but basically I'm creating an array of asteroid size called sizes, which contains one of each of the enum values. Then I'm going to get a random value between 0 and 3, which will give me an index into that array. And I can use that as the next asteroid size. Next, I want to work on generating a different angle for these asteroids. What I'm imagining for this is that when I create an asteroid, say if I want to create it at this location right here, I want to imagine that the center of the screen is kind of the target. I want the asteroid to move toward the center of the screen. But I don't want the asteroid to move literally directly toward the end of the screen so that every single asteroid will end up taking a path directly through the center of the screen, because I think it'll just look very bad. What I think would work instead is that when we choose the position for the asteroid, we basically look at this center and we create an area around the center, and the asteroid must pass through this area. One way to do this is to just draw a circle around the center, pick a random point within this circle, and then make that the target of the asteroid. Another idea that I had in mind was the asteroid will trace what the path is directly to the center, and then it will rotate this path by a random amount within some number of degrees. I'm going to try this approach first, since I think there's a tool in RayMath that I can use to achieve this very easily. I'm creating another preprocessor define, this time for what that angle is going to be offset from the center. Next, when I add the asteroid, I'm going to remove the fact that I need to specify the angle. Since the angle is going to be determined based on what the position is, I don't really need that information. Also, I'm never using this screen size vector2, so I'm going to replace it with screen center. The first thing I'm going to do is use vector2 subtract to perform a subtraction from the center of the screen to the position, which will give me the resultant vector pointing from the position to the center of the screen. Next, what I want to do is normalize this velocity and then scale it up to the desired speed. That desired speed is going to be yet another random value. For now, I'll just make these speeds 100 and 300 pixels per second. The first line is setting what the base angle should be, and then we're setting the scale accordingly. Next, I just need to rotate it based on that offset I defined earlier. I can use the vector to rotate the vector by an angle, and that angle is going to be the float cast of the get random value between the negative asteroid random angle and the asteroid random angle. Now I'm going to want to test this carefully because vector2 rotate might expect degrees, it might expect radians. Currently, it's getting degrees. The way that I'll test this is I'm going to create two arrays, one called line 0 and one called line 1. Each array is going to be of length 2, so I can use it as a start and end position. Before I do this, I'm going to set both lines to have their start where the position was. And then for the end of those lines, I'm going to add the velocity after being rotated to the position and scale that up a bunch. Then after I draw the asteroids, I'm going to draw these lines. So when I set the random angle, I'm going to include this Raylib constant, which will just convert the degrees to radians. And now that's pretty much the cone that I expect to be generated. And we can see that as I spawn these asteroids, they're all heading for the center. I think this is a really neat debug visualization, and I think it's good to keep these kinds of things around. So I'm just going to surround it in a bool which is set to false. I'm going to do the same thing for actually drawing the lines in the draw loop as well. Now I want to get the asteroids to spawn automatically, and I want them to spawn off screen. Instead of using the mouse position, I'm going to use a different function, which I'll make now. If I wanted to get a random point within the screen, it'd be really easy. I can use a random value between 0 and the width for the x, and a random value between 0 and the height for the y. The thing is, I want a point which is off the screen, so I want to do this with one of the values, and the other one I want to deliberately set to something off screen. I can use get random value between 0 and 1, and since I'm in C, 0 will be treated as a false and 1 will be treated as a true. I can use this to choose randomly between two different blocks of code. And within these blocks of code, I can do the same thing again. This is probably one of the hackiest ways to do something like this, but for our purposes, I'm happy with it. So in this case right here, I'm going to set the x value to a random position. I'm going to use these padding values, which for now I'll set to 128, so that when they come from off screen, they're actually being separated a little bit from the edges of the screen as well. Now, this is just allowing me to determine whether or not I want to come from the top or the bottom. So if we hit this first case, that means that we're going to randomize the x value, but half of the time I'm going to set it to either the top or the bottom. And in this case, we want to do almost the exact same thing, except we want to set the y based on the screen height. And in these cases, we want to use the width and the padding. So like I said, this is probably one of the hackier ways to do this, but I'm happy with this for now for our purposes. So when I press the left mouse button, it's going to spawn a new asteroid. Let's give it a shot. Okay, looks like they're all spawning at the edge and moving in. So I've set it up where asteroids are now way off screen. They're super far away and we can't see them, but they're still being updated. And I can't really remove those to make room for new asteroids. Like if a player fails to destroy an asteroid, they're not going to get those points, but eventually that asteroid should just naturally despawn. I'm just going to make it so that there's a fixed amount of time until an asteroid despawns. I'm going to add a float for the creation time of that asteroid. And I'm going to give an asteroid a life of 10 seconds. In asteroid update, I'm going to check if the current time is past the creation time plus the life. And if it is, I'll disable the asteroid and return. Now this is definitely another debug visualization, so I'm going to preemptively add another bool for this. This time I'm going to default it to true so that we can actually see it in testing. If we want to show the asteroid count, I'm going to iterate over all the asteroids, and for every asteroid that's active, I'll increase the count, and then we'll show it. We're never actually setting the creation time, so we're giving all of them a creation time of 0, which means that after 10 seconds of the program even being started, all asteroids will be considered dead. So when we create the asteroid, I'm going to set the creation time to get time. I also realized that in asteroid draw, we're not checking if it's active, so I want to add the same early out that we have in the update case. So I'll spawn 16 asteroids. There they go. Now the lifetime that I gave is probably a little bit extreme. I'll spawn this one. That's a pretty quick moving one. And we'll see that by the time it's gone, I mean, it stays for at least a few seconds after. So I could probably tighten it down a bit. I think it's probably also not a bad idea to actually add some kind of off-screen check. For now, I'm almost happy with this. I just want to make it so that the asteroids spawn naturally over time. I'm going to define an asteroid delay, which I will make 1/4 of a second. I'm also going to have a float, which is last asteroid creation time. So if the current time is past the last creation time plus the delay, then we can create the new one, and we can set the last asteroid creation time equal to time. I'm going to set this to a negative value so that when we start the program, immediately one spawns. Now it's obvious this spawn rate is way too quick for gameplay, so we could probably tone it down a little bit. At this point, we're definitely ready to move forward with adding in some ship controls, adding in the projectiles, and actually getting some more of the logic where asteroids can split off into other asteroids and things like this. But for now, I want to show a quick bonus on how we can add some basic debug tools using raygui so that we can toggle those visualizations that we liked before on and off. First things first, we need to actually get raygui for ourselves. So if you're on the Raylib GitHub, or at least on Ray's GitHub, you can just go right to raygui. I'll also have a link to this repo in the description. Go into source and click on the raygui header file. This is a header only library, so we don't actually need to do any kind of build step. We can just build it as a part of our game. If you click on this icon right here, it'll copy the raw contents. Now going into VS Code, I can add a new file, which is raygui.h, into my source folder, and I'll just paste the contents of what we got from GitHub. Before we can use anything from inside of raygui, we're going to need to provide an implementation. We'll create another file called raygui.c, and in here, I'm going to define raygui_implementation. Then I can include raygui.h, and I'm going to write nothing else in this file. I don't want to put anything else in this file. This file is going to be dedicated to defining all of the functions within raygui.h. When we include this file, it checks to see if this is defined, and if it is, it's going to actually paste the function definitions in here from the file. Otherwise, it'll be treated as just a normal header file that we can use to call those functions from other translation units. Now that's all done, we can include raygui along with raylib and raymath. And now in my draw method, I can start adding some raygui stuff. I'm going to create a rectangle at the bottom of the screen. The way you draw a button in raygui is you can just say GUI button, provide the bounds, and give a text. Now the GUI button returns a bool on the frame that it's pressed. So I'm going to put this in an if statement, and now I can just toggle show asteroid count. Next, I'm going to move the rectangle over a little bit, and I'm going to draw another button. Now that I've added these to my draw loop, and I even have a little bit of logic, let's try building. And we can see we now have these two buttons down here. If I click on this, we can toggle this text. And if I click on this, we can toggle showing the cone of the newly spawned asteroid. Now at this point, I'm going to take one look and say, I've got to pull this angle down just a little bit. It's a little too extreme. And if it wasn't for that debug visualization, I might not have thought to check that. The reason these kinds of visualizations are good is because as you develop the program further, some changes you make will affect other things that you've set up, and you may need to reevaluate how those things work. Before, we were clicking from inside the window, so the angle seemed fine. But now that we're spawning them from outside the window, the angle is way too extreme. So these are really useful to have, but I don't necessarily want them on screen all the time. I would rather have them just pop up when I need them. To do this, I'm going to add one more Boolean, which is show debug menu. And in update, I'm going to check if the grav, tailed, whatever you want to call it, it's the key left of 1. I'm going to check if that key is pressed, and if it is, I will toggle the debug menu. Now, all of this logic I'm only going to do if we want to show the debug menu. Now, if I press this button, I can toggle showing this menu on and off. I can turn on the visualizations and close the menu if I don't care to see them anymore. There's a really good GUI toggle we can use instead. In this case, we want to actually pass the Boolean as the third parameter every time we call it, and we want to just set the bool equal to the result of this, since it will always return what the current state of the button is. Now when we turn one of these on, the button actually stays in a visually toggled state so that we can see that that is actually on. Lastly, there's one more alternative style that we can use. Instead of using GUI toggle, we can use GUI checkbox. The main difference with this one is you're going to want to make the rectangle a lot smaller since you're only defining the size of the actual checkbox, and the label will automatically be placed right of that. So you can see now we have this more checkbox style approach. All right, that's all for today's video. As a recap, we added the asteroid struct. We have them spawning at the edge of the screen and heading towards the center. Every asteroid has their own size, they have their own rotation speed, and they have their own velocity. As a little bonus, we also talked about adding a simple debug menu so that we can have buttons that we can toggle on and off certain visualizations. In the next video, we're going to add a basic player controller that will allow us to actually have a ship cruising around on the screen, wrapping at the edges, and accelerating and decelerating in a way that feels really satisfying. If you're really excited about this series, be sure to drop a like on the video and subscribe to the channel. This is not going to be the last project that I make in Raylib, and they're only going to get more exciting from here.